Hi, welcome to Lesson 29, Session 2. Today we're going to be continuing our work classifying two-dimensional figures. And we will be using our Venn diagrams and our tree diagrams to find out about the different ways that we can put all of these shapes together so that we can see how they all are related. We're going to be working in our Ready Classroom Math workbook on page 591 through page 596. So go ahead and turn to page 591 now. So it says to do this, read and try to solve the problems below. Sort these shapes into the Venn diagram below to show the relationships among parallelograms, squares, rectangles, rhombuses, and quadrilaterals. So here are the shapes that we have. Use at least one shape in each region of the diagram. Classify the shapes by labeling each region with the category name. So, first of all, we know that we have to put some categories on here. Well, where are we going to get those categories from? That's right, they're up here in the problem. So we know that we have parallelograms, squares, rectangles, rhombuses, and quadrilaterals. So we want to think about what is the most general shape that we know that almost all of these shapes go into? What is a characteristic that all 7 of these shapes have in common? That's right, they have 4 sides. So we know that the definition of a quadrilateral is that all quadrilaterals have 4 sides. So right now, if we looked at all of these shapes, we could put all of them into this outer oval because they all have 4 sides. However, a few of them have some more specific attributes that's going to make it go down smaller and smaller. So now we're going to look at parallel. So we know that we've used quadrilaterals, so we're going to go ahead and cross out quadrilaterals. So now we have parallelograms, squares, rectangles, and rhombuses. Now with the work we did yesterday, we know that the next most specific shape is our parallelograms. Because we know that they have 4 sides and 2 sets of parallel sides. There we go. And 2 sets of parallel sides. So we know that any shapes that go in here are going to have 2 sets of parallel sides and are going to have 4 sides. Then from there, it gets a little tricky. So if we're looking at our shapes, we have squares, rectangles, and rhombuses. Now, we know that rectangles are the next, we haven't really dealt with rhombuses yet, but we know that squares, we know where squares and rectangles go. I'm going to be the spoiler alert. We know that square is going to be our most specific. So let's go ahead and put squares in here. Because we know that squares are our most specific because they have, and here we'll do the attributes here. They have 4 sides. They have 2 sets of parallel sides. They have 4 right angles. And they have 4 equal sides. Now, oh, you can't see any of that. Sorry about that. So we know that these are all the attributes that a square has. So 4 sides, 2 sets of parallel sides, 4 right angles, and 4 equal angles. Now we know that we need to put rectangles and rhombuses on here. And since there's only 2 ovals left, we're going to go ahead and put rhombuses here. And I'll talk about those in a minute. Rhombuses and rectangles. So rectangles have 4 sides, 2 sets of parallel sides and 4 right angles. Rhombuses have 4 sides, 2 sets of parallel sides, but what makes a rhombus different from a rectangle is a rhombus has 4 equal sides. That's why a rhombus is sometimes a square, because squares also have 4 sides. Squares also have 2 sets of parallel sides, but rhombuses do not have 4 right angles, but rhombuses do have 4 equal sides. So a square can be called a rhombus, a square can be called a rectangle, a square can be called a parallelogram, and a square can be called a quadrilateral. So a square can be any of these other shapes. Rhombuses, can rhombuses ever be called a rectangle? No, they cannot. Because what is it that rhombuses have that rectangles do not? That's right, 4 equal sides. What do rectangles have that rhombuses do not? That's right, they have 4 right angles. So that's why a rectangle could never be a rhombus. Where they do overlap is where is in square. A rhombus can be a square, a rectangle can be a square. Okay, so now we got out of the way the labeling of the Venn diagram, and we talked about the attributes of each of those shapes. Now we're going to look at each of these shapes and decide where they go. So letter A, we're looking at the attributes. So does it have 4 sides? Yes. Let's go to the next area and see if it could be a parallelogram. Does it have 4 sides? Yes. Does it have 2 sets of parallel sides? Does it have any sides that are parallel? No, it doesn't. So we know that this shape here can only be classified as a quadrilateral. So we're going to put that letter A in the quadrilateral rectangle. Excuse me, the quadrilateral oval, because shape A cannot be a parallelogram. It cannot be a rhombus, a square, or a rectangle. Now let's go to shape B. Now shape B, does it have 4 sides? Yes. Does it have 2 sets of parallel sides? Yes, it does. They're both parallel. Okay, so now, does it have, so we know it has 4 sides, we know it has 2 sets of parallel sides. Does it have 4 equal sides? No. Does it have 4 right angles? No. So shape B is a parallelogram. Now we look at shape C. Most of you could probably recognize what shape C is right off the bat, but let's look at the attributes. We see that it has 4 sides. We see that it also has 2 sets of parallel sides. Are all the sides equal? No, they are not. Does it have 4 right angles? Yes, it does. So we know that it must be a rectangle. Then we look at shape D. Shape D has 4 sides. It has 2 sets of parallel sides. It has 4 right angles, and it has 4 equal sides. So shape D must be a square. Shape E, does it have 4 sides? Yes, it does. Does it have 2 sets of parallel sides? Yes, this side is parallel and these sides are parallel. Does it have 4 right angles? Nope, no right angles. Does it have 4 equal sides? Yes, it does. So since it has 4 equal sides, shape E is a rhombus. All right, then we have shape F. Shape F has 4 sides. It has 2 sets of parallel sides. It has 4 right angles. Are they equal? No. So shape F is also a rectangle. And then finally, shape G. Does shape G have 4 sides? Yes. Does it have 2 sets of parallel sides? Nope. Those are not parallel. In order for them to be parallel, they would never cross. So these are not parallel. So we know that shape G must be a quadrilateral. And that is how we classify all of these different shapes using a Venn diagram. All right, let's go ahead and go to page 592. On page 592, it says we are going to explore ways to understand classifying two-dimensional figures using a Venn diagram. So we did that. Now, they went through and said, okay, now that you've used the Venn diagram, which we did on the front page, we can also use a table to compare properties of the categories of polygons. So for example, and we kind of did this on the last page, we talked about all their different attributes. Parallelograms have 4 sides, 2 pair of parallel sides, and then they also talk about 2 pairs of sides with equal length. Those are all attributes of a parallelogram. Attributes of a quadrilateral, they only have 4 sides. Rectangles have 4 sides, 2 pair of parallel sides, 2 pairs of sides with equal lengths, and they have 4 right angles. A rhombus has 4 sides, 2 pairs of parallel sides, 2 pair of sides of equal length, and 4 sides of equal length, because all sides are equal, so this one automatically counts. And then squares, being the most specific, actually have all of these categories. So what makes a square different from a rhombus is that a rhombus doesn't have right angles. What makes a rhombus different from a rectangle is that a rhombus has equal sides where a rectangle does not. Quadrilaterals are the most general because they have really barely any attributes. And then parallelograms only have a few attributes, which makes them more general, where the squares are most specific. Now, looking at the model, it says you can show the relationship among the categories with a Venn diagram, which we did on the last page. 2 regions of the Venn diagram are labeled, and 3 of the shapes have been classified by placing them into the diagram. Write the remaining category names and the letters to figure C, D, and E, and F in the diagram. So we already did this on the last page. We know that this is square, and that was shape D. We know over here we put rhombuses, and that was shape E. And then we had rectangles, and that was shape C and shape F. Now we're going to connect and just make a few connections about what we see over here on the table and in the Venn diagram, and what we see on and the questions that go along with it. So looking at the quadrilaterals column, so looking at this column here in the table and the placement of shapes A and G in the Venn diagram, why are shapes A and G placed in the outermost oval? So shapes A and G are in the outermost oval because they are shapes that are the most general. The only property that they share with the other shapes is that they have 4 sides. So they're the most general because these 2 shapes the only attribute that they have in common is that they have 4 sides. They have none of the attributes of parallelograms, rhombuses, squares, or rectangles. All right, number 2. Explain how the Venn diagram supports this statement. All parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. Again, let me point and say that at the same time. All parallelograms are quadrilaterals, but only some quadrilaterals are parallelograms. So the reason, or what I came up with, was that the oval for parallelograms is completely inside of the oval for the quadrilaterals. A parallelogram has all the properties of a quadrilateral, or the only property. So if you look on the table, the parallelogram has all that quadrilaterals have, but a quadrilateral does not have all the properties of a parallelogram. For number 3, we're going to be looking at the table. Which categories share all the properties listed for parallelograms? So if we're looking at parallelograms, we're looking for shapes that have 4 sides, 2 paraparallel sides, and 2 pairs of sides of equal length. So rectangles have, yeah, yeah, yeah. Rhombuses, yep, yep, yep. Square, yep, yep, yep. Quadrilateral, well, it has one, but it's missing the other 2. So the only shapes that have all the same qualities of a parallelogram are rectangles, rhombuses, and squares. So how is this shown in the Venn diagram? If you look in the Venn diagram, we have the oval for parallelograms. And inside the oval for parallelograms, we have rectangles, rhombuses, and squares that are all inside of the oval. So they're in their own ovals, but all of their ovals are inside of the parallelogram oval. So that's how we know that all of these 3 shapes could also be classified as a parallelogram. Number 4, looking at the table, which properties are not shared by the rectangle and the rhombus? So if we look at rectangles and we look at rhombuses, which properties are not shared? So I'm going to say rhombuses have equal sides. Rectangles do not. Rectangles have 4 right angles. Rhombuses do not. All right. How is this shown in the Venn diagram? The 2 ovals, they overlap where we see the square, but neither oval is completely inside of the other, or neither oval is totally inside the other. So therefore, we know that a rhombus can never be a rectangle, and a rectangle can never be a rhombus. Number 5, look at your Venn diagram. Why is shape D inside all of the ovals? Well, we know that. A square shares all the properties of the other shapes. A square is the most specific shape. So we know why that one's there, because it's the most specific. It has everything in common with rhombuses, rectangles, parallelograms, and quadrilaterals. Now, for our reflection today, what is the strategy that you like best when you're classifying 2-dimensional figures? Do you like using this table? Does that make a little bit more sense to you? Or do you like using a Venn diagram? I want you to tell me what is your best method, and then tell me why. And then you can pause the video and finish writing, and then when you're done, you can turn the page to page 594. All right, on page 594, we're going to go ahead and do some work with trapezoids. Now, we have not talked about trapezoids yet, but trapezoids are a little tricky because mathematicians define trapezoids in 2 different ways. So there's inclusive trapezoids and exclusive trapezoids. So trapezoids, so here are the 2 definitions. Trapezoids are quadrilaterals with exactly, that's the big word there. I'm gonna even highlight it because I want you to see that. Exactly 1 pair of parallel sides. So this type of trapezoid is called an exclusive. Meaning if you classify a trapezoid this way, it has to have only 1 pair of parallel sides. So if you think of a trapezoid that way, then it's going to change the way that our Venn diagram looks. The other way you can think about a trapezoid is that trapezoids are quadrilaterals with at least one pair of parallel sides. And this is called inclusive. And now I'm starting to second guess myself, so I'm going to go ahead and check that out. The way that I can check it out is I can go to the glossary in the back of my math book, and I can look up the word trapezoid in the back. And so, oh, good, I did it right. And we can find the definition of an exclusive trapezoid. An exclusive trapezoid is a quadrilateral with exactly, remember I highlighted that, exactly one pair of parallel sides. That's what makes it exclusive. You can only have one pair, so it's very exclusive. And then a trapezoid is inclusive because it says you only have to have at least one pair of parallel sides. We don't care if you have two, you just have to have at least one pair. So this definition for trapezoid is inclusive. It's inviting all types of people to be a trapezoid. So those are the two definitions for a trapezoid. So just be careful that you look and see which definition are they looking for. So if we're looking at our question number 7, and we're thinking about the two different types of trapezoids, the exclusive, which means you have to have exactly one pair, and the inclusive, meaning you just need one pair, we're going to write the word exactly one pair into one of these Venn diagrams, and then we're going to write at least, one pair in underneath one of these two diagrams, based off of where trapezoids are in the diagram. So when I think of the word of inclusive, that means we're bringing it all together, and it's okay if you only have one set of parallel sides. It's okay if you have two parallel sides. We take all parallel sides. So which of these pictures shows that trapezoids are including all the other shapes with it, meaning they're including even those shapes that have two sets of parallel sides? That's right. It's this one over here. So we're going to write at least one pair underneath this picture. They're being very inclusive by allowing the parallelograms and rectangles to also be classified as trapezoids because they happen to have two pair of parallel sides, but it's okay. Trapezoids don't mind. Well, inclusive trapezoids, that is. Now, then we have exclusive trapezoids. Exclusive trapezoids are like, no, you can only have exactly one pair of parallel sides. And so that means in order to be called a trapezoid, you have to only have one set of parallel sides. So as you can see here, the trapezoids are excluding themselves from the other shapes because they have only one set of parallel sides, and parallelograms and rectangles have two sets of parallel sides. So here you have to have exactly one pair of parallel sides. This would be the exclusive trapezoid. All right, number 8. Sort these shapes into the Venn diagram based on properties of having parallel sides and having perpendicular sides. Now again, I'm going to go back to that glossary and make use of it because I need to see what perpendicular sides are. I mean, I'll tell you I know, but I want to model what I would do if I didn't know. So I would go back to the P section of my graphic organizer, and I would find the word perpendicular lines. Perpendicular lines are two lines that meet to form a right angle. So this line and this line are perpendicular because they meet to form a right angle or a 90-degree angle. Meaning if we looked at this angle here, it is 90 degrees. Okay? So we're going to look here and we're going to decide which of these shapes, let's get a zoom focused, there we go. So we're going to label the two categories. The category on this side is shapes with parallel sides, and over here on this side is the shape with perpendicular sides. Now, this oval over here is going to only have outside of this tiny oval is going to be shapes with parallel sides. On this side of this oval are going to be shapes with perpendicular sides, and then in the center are going to be shapes that have both parallel sides and perpendicular sides. Okay, so let's look at shape A. Shape A definitely has parallel sides. This side is parallel to this side, and this side is parallel to this side. But does it have perpendicular sides? Do these two lines, when they intersect, does it form a right angle? No, it does not. So shape A has parallel sides, but they are not perpendicular. Shape B. Shape B has two sets of parallel sides, so yep. And it also has perpendicular lines that form a right angle. It actually has these two lines are perpendicular, these two lines are perpendicular, these two lines are perpendicular, and these two lines are perpendicular. Lots of perpendicular sides there. So shape B comes in the middle here. Then we have shape C. Shape C definitely has parallel sides, but do we form right angles? No, we do not. So shape C goes over here. Shape D has no sets of parallel sides, but it definitely has one right angle. One right angle. So shape D comes over here. Now we're going to look at shape E. Now, I forgot to mention that we only are looking for shapes with parallel sides, not how many parallel sides they have, just how many have parallel sides. So shape E here, does it have any parallel sides? Yes, this top and the bottom line are parallel to each other. They're never going to touch, no matter how long they go. But the other two lines are not, but that's okay. Do we have any right angles? Nope, no right angles. So shape E comes over here. And then I'm going to fix that shape D. It's not looking so pretty. I like to have it look good. There we go. And then finally, shape F. Shape F definitely has parallel sides, and it has right angles. So shape F is going to go over here. And then finally, for number 9, it says, what definition in problem 7, so if we're looking back at problem 7 with the inclusive trapezoid and the exclusive trapezoid, which lets you classify shape A? So we're looking at this shape here. The shape A in problem 8 as a trapezoid. So which is this shape A? We know it's a shape with parallel sides. We know it has two sets of parallel sides. So which of these definitions of trapezoid would be the one that would allow this shape to also be classified as a trapezoid? Shape A is a parallelogram with two sets of parallel sides. So it can be classified as a trapezoid using the definition that a trapezoid has at least one set of parallel sides. We know that that is the inclusive definition of a trapezoid. So with that, go ahead and get that written down. You can pause the video if you want to finish it. And then you're going to do pages 595 and 596 on your own. If you have any questions, email your teacher. See you next time.